All right, as promised, I said that I would come back to the part of the notes that we didn't get to finish. I am going to do a really quick recap on the previous night's homework because I think a few people still had some questions. So using graphs to evaluate compositions of functions. Okay, so the first thing is start on the inside function. So if you're having trouble with this, you should write these steps down. So you start on the inside function. So the inside function meaning like this function right there. So we're going to start with the inside function. And so that would be graph J. And so on these two, this is graph J right here. It says it right here. And this one is graph K. So we'll start on this graph. And this is our input. So look for input value. Remember, input is also called your x value or your horizontal axis. So we're going to the horizontal axis, right? We're going to find the number 0, which is right here. And then we find the output value. And that would be our y value. So at 0, the output is 0. Okay, so j of 0 is 0, but we're not finished. Now we go to the move to the outside function, which is k. So I'll go over to k, and I'm going to use my, so output value is new input, meaning x value. So 0 is the number I'm looking for, this 0. So on the x-axis, 0, and then move up or down to your function. So again, we're going to look or find, so I should say find output, meaning the y value. Okay, so at 0 on this graph, 0 is right here. Go up to the graph. That point would be right there. That's the point 0, 1. And that is my output, 1. Okay, I'll do that again. I'm going to do, I'll do this one right here, number 19. So j of 3, we're going to go to j and find 3. J of 3 is right here. That's the point 3, negative 3. I use my output value, right? So find my output value. I found it. It's negative 3. So j of 3 equals negative 3. Now that's going to be my new input value. I'm going to move to the outside function, and my output value is my new input. So my outside function is k. So I'll move over here to k, and I'll go to negative 3 on k. Negative 3 is right here. And move down to my function. It's negative 3, negative 2. So my output is negative 2. I'll do one more, maybe like when it has like j of j or k of k. I'm going to do j of negative 2. So j of negative 2, j is over here, of negative 2 is 2, right? Negative 2, 2. So j of negative 2 is 2. Now I'm going to use this value on the outside function, which is j again. So I'll go to 2, and I'm down here at negative 2. All right, so that's an example of using a graph. Now let's flip over to using the table. So we're using, I'm kind of going to put these like this so we can see what we're doing. So I'll go over these ones again. F of 3, this is F, right? This is G. F of 3, so these are our inputs, remember. The steps are still the same. Instead of using, I'm not going to rewrite those steps. They're right here, right? So start on the inside function, look for the output value, look for the input value, find that output value that corresponds to the input value. Move to the other function, the outside function. Use your output value is your new input value, and then find the new output value. Okay, so we're going to do the same thing again, only this time we're only using F. F of 3, this is our input, or our X. And then we're going to see what our output is. F of 3 is 1, our y value. G of 3, the output is 2. Okay, now G of f of 3. Again, start with your input on f. Your inside function, so f. So we're going to find f of 3. Our input is 3, our output is 1. So f of 3 is 1. That's my new input. My input g, go to g, the other function, g of 1 is 4. And similarly, right, this time we're going to start on g though. What is g of 3? G of 3 we already know is 2. But g of 3 is 2. That becomes my new input. Go over to f, the outside function. F of 2 is 2. Okay, so they want us to do the same thing to fill in this table, this table right here. Now using different notation. So this is the same notation as this. They're telling you off to the side. And there was a typo here, and in class I fixed it. Remember, I said f of g of x is the same as f of g of x. Okay. So we're going to start with the inside function g and then move to the outside function f. So g of 1. So g of 1 is 4. Then we go to the outside function and we use 4 on the outside function. F of 4 is 4. G of 2 is 3. F of 3 is 1. G of 3 is 2. F of 2 is 2. And G of 4 is 1. F of 1 is 3. On this table, we're going to do the same thing, but backwards. So we're going to start on F of 1. F of 1 is 3. Then move to G of 3 is 2. F of 2 is 2. G of 2 is 3. F of 3 is 1. G of 1 is 4. And F of 4 is 4. G of 4 is 1. Okay. All right, we already talked about these in class as well. Okay, now we've done this with a graph. We've done this with a table. Third one is to use equations. All right, so this was where we stopped in class. We didn't have time to get to this. So if you just wanted to fast forward to this, that's fine. But for those of you who were having a little bit of trouble, I went ahead and went through all of it. All right, so we still have the same steps. So again, we're going to start with the inside function. And we're going to evaluate, meaning substitute, the value given. So the value given in this case is 2. So they want us to find f of 2. So we're going to use this function, right? So f of 2. So plug in 2 into our function, which is right there. So, and then when I say substitute in 2, I mean anywhere there's an x. So that you might have more than one spot to substitute it in. On these, we only have one spot to sub it in, but you may have more than one spot. And so f of 2 is 2 squared, which is 4. Okay, so now we're finding g of 4. So now we take, so then the next step, right, after you evaluate it, then you substitute that value in. So substitute the value you got into the outside function. And then you simplify. Okay, so we're going to substitute 4 into g. G is right here, 2x minus 1, and I'm going to substitute in 4 for x. So that gives me 8 minus 1, which is 7. So my answer, my final answer to this, g of f of 2 is 7. right, we're going to do that again. We're going to find g of 2 because we're starting with our inside function. So I'll start with this function, g of 2. And g is 2x minus 1. But I'm going to substitute in 2. So that gives me 4 minus 1, which is 3. Now I'm going to use that value in the outside function, which is f. So g of 3. I'm sorry, which is f, and I just wrote g. F of 3. All right, f of x is x squared, so x squared, and we're going to substitute in 3. 3 squared is 9. And so f of g of 2 is 9. And that's our final answer. Why don't you guys try this, you try, using the same functions, g of h of 3. All right, go ahead and pause here and try it. See if you can get the same answer that I get. I'm going to go ahead and go through it. So I'm going to start with h of 3. H is 4x minus 3. I'm going to substitute in my value of 3. That would be 12 minus 3, which is 9. Now I'll take 9 and substitute it into g of 9. And g is 2x minus 1. And I'm subbing in 9. So 2 times 9 is 18, minus 1 is 17. So g of h of 3 is 17. I hope this is getting a little easier for you. All right, okay, now the rules do change a bit here. I shouldn't say they change, but we do want to start instead with our outside function whenever we're doing this in terms of x. So we're going to switch this up a little bit. All right, I'm going to go ahead and start on a separate sheet of paper. I'll rewrite my 3 functions. So f of x equals x squared, g of x equals 2x minus 1, and h of x equals 4x minus 3. All right, so we're going to do the first two, a and b, and then I'll give you guys a couple extra examples to try. So the first one, a, right, it says to find g of f of x. I'm going to write the steps off to the side here. And so what we do, right, is instead of starting with the inside function, you're going to write your outside function, leaving and opening wherever you have an x. So again, this could happen in more than one place in the function. It may only happen in one place. All right, so I'm going to write my outside function. My outside function is g. So g, I don't need to write the g, I'm sorry. G of x is 2x minus 1. It says leave an opening wherever I have x, so that's what I'm doing. And then step 2 is to substitute the inside function into the opening. So my inside function is f. So I'm going to substitute that in right there. And then my third step is to simplify. All right, simplify means if you can multiply, distribute, combine like terms, whatever it is that you need to do, you're going to simplify that function. And so that would be 2x squared minus 1, right? 2 times x squared. These are not like terms, they cannot combine. Therefore, g of f of x is 2x squared minus 1. All right, for b, it says f of g of x. So we're going to, again, start with the outside function, leave an opening where x is. The outside function is f. So we're going to have x squared. And then we're going to substitute in g into that function, which is 2x minus 1. Now, I'll remind you, there's no distributing. This third step is simplify. That's where I'm at now, is simplify. There's no distributing the squared, right? The distributive property is for multiplication, not for exponents. So we're going to rewrite this as 2x minus 1 times 2x minus 1. So this is the simplify part. Remember last semester when we squared a binomial, you have to rewrite it like this. And then you can use a generic rectangle to multiply your 2x minus 1 times 2x minus 1. That's 4x squared minus 2x plus 1. And then combine like terms, they line up right there. So this would be 4x squared minus 4x, watch your signs, and then plus 1. All right, I'm going to give you another example to see if you can follow it. So I'm going to say, why don't you try this one? Try g of h of x. G of h of x, using these same three functions. So pause here, try it, see if you get it correct. All right, I'm going to begin it. So I start with my outside function, which is g, 2x minus 1. And I'm going to substitute in h into this function. And h is 4x minus 3. And now I'm going to simplify. Last step. So simplify, I have to distribute that 2 through. That gives me 8x minus 6. And then bring down the next term, which is negative 1. Combine like terms. So I get 8x minus 7. Watch your signs. I'm going to give you another example to try. So let's try h, this is going to be example D, h of f of x. So I'm going to take h, because that's my outside function, 4x minus 3, and I'm going to substitute in f. F was x squared, and then that would give me 4x squared minus 3, 4x squared, sorry, minus 3, and I am done. Hopefully these are getting a little easier. I like using the colors. It kind of helps me to remember what I'm multiplying and what I'm substituting in. Have a great weekend. Don't forget to do your homework.